Welcome everyone in this NPTEL online certification course on biological process design for wastewater treatment. So, today we are going to start another section within this course, and this section is with respect to sludge management. So, in the wastewater treatment, during various operations which are carried out, lot of sludge or solid waste or biosolids are generated, and these biosolids are more generated during the biological process design. So, biological processes like activated sludge process, tickling filter and various other operations related to biological processes, they generate lot of sludge. In addition, we have sludge or solid waste which are generated during physico-chemical treatment of wastewater also, like during coagulation and flocculation, and so during settling we get all these solids, and these solids or sludge or biosolids have to be managed properly, and this is very important section that we should properly understand the sludge management, what are the different specs, how they have to be carried out. So, the sludge designates the solid byproducts from wastewater treatment. So, the solid byproducts which are obtained during the wastewater treatment, they are designated as sludge. So, what happens is that during biological treatment, the organic matter is absorbed by the microbial biomass, and then it is further converted into further microbial biomass. So, that means during biological treatment the organic matter is taken as a nutrient by microbial biomass. So, they convert that into CO2, but because they are using them as a nutrient, the biomass also grows. So, generally this process under which the byproduct which is obtained, it is called as biological or secondary sludge or biosolid. So, when we refer anything as biosolid, it emphasizes its beneficial aspects, like giving more value to the productive uses. So, anything if it is solid, then it has lesser productive value as compared to biosolids, but generally we have other operations also which may incur more cost also, like for other type of solids the only utilization may be that they have to be disposed of in the landfill or they may be incinerated, but biosolids may have other uses also. Okay. Now, the management of sludge originating from wastewater treatment plant is highly complex and costly activity. So, that is why we have a special section on sludge management, through which we will be learning all these complex activities and which are costlier also. The sludge represents only 1 to 2% of the treated wastewater volume. So, whatever is the volume, it may vary little bit more also, but this is the range. However, the management if we carried out of this sludge, which is highly complex in nature, the cost will be around 20 to 60% of the total operating cost of the wastewater treatment plant. So, that means the sludge is very important, we have to take care of the sludge very well, otherwise the cost may increase from 20 to 60%. Also, the perception of the people who are living outside the wastewater treatment plant, that relies on this sludge generated, because we have to transport this sludge. So, how much volume we are generating and how much we are transporting it outside the premises of wastewater treatment plant, that also generates lot of perception among the people who are living near the wastewater treatment plant or other places. So, this sludge management is very important, though it is highly complex in nature. The final sludge destination is also a complex operation, because that sludge management will frequently be undertaken outside the boundary of the treatment plant. So, we have various issues and challenges which may occur during the sludge management. So, we this today onwards will be having few lectures which will be totally dedicated to sludge management, which the sludge which is generated during biological treatment or during physico-chemical treatment also. So, the content for this section includes that we will be concentrating on the sludge characteristics and production. So, that means we will be studying within that the sludge characteristic at each treatment stage, how much it is generated, then is there any fundamental relationship in the sludge generation, okay, or characteristics. So, that also we will try to perform. Then we will see that can we perform some calculation, basic calculation with respect to how much sludge will be produced. So, this helps in beforehand designing the treatment plant as well as the sludge management section. Then we have during operation what are the steps that have to be taken care for sludge management. So, this includes sludge stabilization, which itself will include both anaerobic and aerobic digestion. So, whatever we studied during anaerobic and aerobic biological wastewater treatment processes, some of them will be understood here also. So, in the sludge management also the concepts are similar to the wastewater treatment. Now, then after sludge stabilization we have sludge thickening and dewatering. So, we will study regarding the gravity thickening or other methods, and then the sludge drying beds. Also the pathogen which are there in the sludge, that is very important. So, we will have a section related to pathogen removal from the sludge. So, which is given. So, we will try to understand the mechanisms to reduce the pathogens. Those mechanisms may include thermal, chemical, biological or radiation treatment. So, we will have a subsection devoted to that. Then processing to reduce the pathogens, that includes composting. Finally, we will be having section on sludge transformation and disposal methods. So, the sludge transformation that we will be studying include thermal drying, wet air oxidation, incineration, and finally landfill disposal. So, now each section will be studying one by one. So, now we will start the section on sludge characteristics and its production. So, the sludge characteristics and production, the amount of sludge which is produced in the wastewater treatment plant can be expressed in mass, like a gram of total solids produced per day on dry basis, also on volume meter cube of sludge produced per day on wet basis. So, we can report like this. In biological wastewater treatment, part of the COD which is converted into biomass, that makes up the biological sludge. So, this is what is we produce during the sludge production. So, we have to take care how much is converted into biomass. So, that will give idea that how much is the production. Okay. Now, the characteristics and the quantities of sludge which are produced in various treatment systems is given or in this slide. So, there are different content also, like a wastewater treatment plant, you can see here the sections which are listed here. So, primary treatment, if the conventional methods are there, then the primary treatment in the septic tanks, then if we have facultative pond which is there. So, that means both anaerobic and aerobic. So, then we can there, then if only anaerobic pond is there. So, what is the production, then facultative aerated lagoon and complete mixed aerated sedimentation pond also. So, in this table actually there are 4 columns which are there, and they each report 4 different things. Okay. So, first thing is how much kg of suspended solid is produced per kg of COD applied. So, tentatively we can have idea that how much production takes place. So, based upon that we can tentatively calculate beforehand also. So, this data has been compiled based upon the various reported, and this is from this particular book, this volume which is giving this data. So, then we have dry solids content. So, how much is the dry solid content out of the total. So, that means we have lot of water is getting produced in the solid. So, dry solid content is very less. So, we have to see this is very important section, because the post processing will depend upon that. So, how much is the solid content, but how much is actually the dry solid content, that also we have to see. The mass of sludge also we can tentatively calculate back based upon the how much wastewater is getting generated. So, tentatively mass of sludge in gram SS per inhabitant which is produced per day. So, this calculation gives, if you are planning for any community or any city etc., which we can do, and then similarly we can go for calculating the volume of sludge in liter per inhabitant per day we can calculate. So, these are very important data which help in the planning of any wastewater treatment plant and further understanding that how much sludge will be generated if we are going for conventional primary treatment or anything, and how we can further take care of the sludge management issues before actually we have installed the plant, etc. So, this is there. Similarly, in the further we have the for septic tank and anaerobic filter, the data is given. If we have septic tank, which is the common in a very small residence, etc., then conventional activated sludge. So, we have primary sludge, secondary sludge which is produced and total. So, we can see that 0.6 to 0.80 kg suspended solid is produced per kg COD which is applied, and that the dry content is less, okay, and per inhabitant calculations also we can perform. So, from here onwards we are coming to the system which are at a larger scale. So, we have like conventional activated sludge, then activated sludge which is having extended aeration. So, we can see little bit drop happens with respect to kg SS per kg COD because we have extended aeration. So, these data help in determining the amount of solid content which is produced per kg. So, similarly for high rate trickling filter, then submerged aerated biofilter we have. So, we have primary sludge, secondary sludge. So, we can see tentatively, if you see the range varies highly from 0.2 to 0.8, tentatively you can see from like somewhere 0.2, 0.8. So, this is what is coming if you roughly take the data. So, maximum amount of SS which is produced is roughly 0.8 per kg COD applied. So, if we want to be on the safer side, similarly you can see in the USB reactor very less amount of suspended solid is produced as compared to in the aerated system. Then USB plus aerobic post treatment. So, here the some increase happens with respect to amount of total solid which is produced per kg COD applied. So, this is there. So, inferences which can be drawn from the previous table, we will try to summarize them. So, table presents mass of suspended solid wasted per unit applied COD. So, considering typical efficiencies of COD removal from several treatment plants. So, this table gives this, and which is the most important data which is reported from that table. Now, considering that every inhabitant, okay, contributes approximately 100 gram COD per day. So, if we assume that each inhabitant produces 100 gram COD per day, that means 0.1 kg COD per inhabitant per day, the per capita SS or suspended solid contribution can be calculated, and which is given actually in the table. So, this is the data that we can roughly we can calculate. Now, also there are some other conclusions. Stabilization ponds generate smaller volume of sludge because the sludge produced in the pond is stored for years in the bottom and it undergoes digestion and thickening, which generally reduces its volume. So, the stabilization ponds produce lesser amount of or lesser volume of sludge. Conventional activated sludge systems produce the largest sludge volume, and that has to be handled further. So, to be treated, this sludge is not digested in the aeration tank because its residence time, the age is too low for doing any digestion. So, that is why we have very large amount of sludge getting produced from conventional activated sludge, where the residence time is only in few days only. Okay. So, going further, the sludge characteristic at each treatment stage. So, the sludge characteristics we can see they vary as the sludge goes through several treatment stages, which we will be studying further. The significant changes are like during thickening and dewatering, increase in the concentration of total solids will happen. So, the total solid which is there will be increased, but there will be reduction in sludge volume. So, because we are going for thickening and water is getting removed. Now, if digestion is performed, then the decrease in the load of total solids happens. So, we have the volatile suspended solid VSS fraction of the total SS will be reduced. So, this happens during digestion process. Now, the sludge characteristics in each stage of the treatment process is defined here, though the table is little bigger, you can pause the video anytime to further understand. Okay, so, the wastewater treatment plant, we have primary treatment, then septic tank, facultative pond, anaerobic pond, then facultative aerated lagoon, etc. So, here the sludge removed from the liquid phase. So, sludge mass gram SS per inhabitant per day and its dry solid concentration is given in the first column. Then if we go for thickened sludge or digested sludge, how much the variation taking place. Now, finally, the dewatered sludge is obtained. So, dewatered sludge contains, like if the sludge mass is gram SS 35 to 45, then in the range for sludge mass for the after dewatered stage will be around 25 to 28. So, the dewatering may be done by any of the process which is given. So, if drying bed is used, filter press or centrifuge or belt press, depending upon that, and the dry solid concentration, this is important, and this has to be done if we want to process the sludge. So, from 2 to 6% or maximum you can see for facultative pond it will be 10 to 20%, then also for anaerobic pond 15 to 20%. So, maximum the drying solid is around 20% without any treatment. When we dewater the sludge, the concentration goes up to 40 to 45%. You can roughly see that it goes up to 40 to 45% of the solid that we obtained ultimately contains 40 to 45% dried solid. So, this is there, and we can roughly calculate the per capita volume in liter per inhabitant per day. So, this is the data which we can take. So, we will be using this data for lot of process, we have to use it for design of the systems etc., and further uses also. So, table is further continued for septic tank and anaerobic filter, the conventional activated sludge, where we have primary sludge, secondary sludge, mixed sludge. So, we can see that after drying we can use any of the process, drying bed, filter press, centrifuge, belt press. So, anything is possible, but the content, the drying solids ultimately increase to 40% from whatever is the initial drying solid concentration. And here, like for conventional activated sludge process, the thickening can be carried out. So, thickening can be carried out by a gravity method, flotation method or centrifuge method. So, when we are doing thickening of the conventional activated sludge process, the from 2% it will increase to 8%, then we do the digestion, okay, and ultimately dewatered sludge will contain only around 35 to 40%, the solid content will be there on the dry basis. Similarly, we have activated sludge, extended aeration process, high rate trickling filter also. So, we can see for these systems we are performing the thickening also, digestions also. So, like for mixed sludge from trickling filter we have the thickening which is carried out. So, the concentration of the dry solid increases from 1.5 to 4% to 3 to 7%, then digestion will be done. During digestion it will remain roughly the same, but after drying it will increase to 40%. So, depending upon the type of drying that we use, whether drying bed or filter press or centrifuge or belt press. One thing which is not mentioned here is that depending upon the drying process that we use, the residence time or the time it takes for drying is different. So, that aspect is very important. Also cost is also different. So, that we will be discussing later on, but here idea is being given that how the characteristic of the sludge changes during various stages of its management. So, similarly for submerged aerated biofilter, USB reactor also the same ideas are given here. Tentatively it will increase from 3 to 6% to up to 45%. This table now will wind up. So, we similarly for USB plus activated sludge system, all the data is given, we can use them. Now, let us try to solve one problem related to the tables that we have used till now. So, here the question is given that for a 1 lakh inhabitant wastewater treatment plant. So, we have 1 lakh inhabitant and for which we are making a wastewater treatment plant which is composed of a USB reactor. So, we have a USB reactor containing treatment plant. So, estimate the amount of sludge that will be produced in each stage of its processing. So, this is the data that is given. Now, we can calculate this using the table that we have given earlier. So, the sludge removed from the USB reactor is to be directed for the treatment stage. So, from the table for sludge withdrawn from USB reactor we can go and we can cross check. So, sludge withdrawn from the USB reactor, if you go back and cross check, it is given that 12 to 18 gram SS is produced per inhabitant per day. We can cross check this also here for USB reactor, this is you can see 0.12 to 0.18. So, this data is taken here. So, 12 to 18 gram SS is produced, okay, sorry, this data is for USB reactor, this data mass of sludge gram SS produced per inhabitant per day. So, 12 to 18 is produced. So, this data is taken. Now, the per capita volumetric production is also we can refer to the table and it will be 0.2 to 0.6 liter per inhabitant per day, assuming the intermediate value. So, in place of 12 to 18 we can take any intermediate value, similarly here also. So, assuming the intermediate value of 15 gram inhabitant per day. So, amount of the sludge which will be there, the SS load in the sludge will be 15 gram per inhabitant per day. So, roughly 1500 kg of SS will be produced per day and the amount of sludge that will be produced we can roughly take, it will be 40 meter cube per day. So, that means we have to handle 40 meter cube of sludge per day which itself will contain around 1500 kg of SS, and for this we have to design a wastewater or sludge management strategy, and that strategy will be dependent upon other parameters also, like we can cross check that what is the solid content actually on dry basis or wet basis. So, those data also need to be calculated. Now, dewatered sludge that has to be finally sent for final disposal or for further usage, it is possible we can go for incineration or anything. The surplus sludge removed from the USB reactor is already thickened and digested, and only dewatering prior to final disposal as a dry sludge is done. So, assuming that the dewatering is accomplished in a sludge drying bed. So, if we assume that okay, what type of dewatering process we are going to use. So, we can use different types of dewatering techniques as discussed earlier. So, depending upon the dewatering technique, this data will vary, but we are assuming the sludge drying beds to be used. So, table earlier shows that the per capita mass production of dewatered sludge remains in the range of 12 to 18 gram SS per day, whereas the per capita volumetric production is in the range of 0.03 to 0.6 liter per inhabitant per day. So, using the average values we can calculate the SS load in the sludge. Again it will remain the same 1500 kg SS, because SS will remain the same, it will not go off, we are only dewatering the volume. So, the volume reduction will happen, it will become 4 meter cube per day in place of 40 meter cube per day. So, the amount of volume of sludge that has to be handled and that will be sent for disposal or for other any use if possible, that will be 4 meter cube per day. Assuming that, now we have to further assume that what is the specific weight of the sludge. So, whether it is how much above the water. So, if we are assuming specific weight to be 1.05, just slightly above water, the total sludge mass, dry solids plus water to be sent for final disposal will be around 4.2. So, 4.2 ton per day, this is ton, this one ton. So, 4.2 ton per day, that means 4200 kg has to be handled, which itself will contain around 1500 kg SS per day. So, this is the rough calculation that can be used further on for performing various calculation. So, this is the rough idea that we have obtained. So, today we learned regarding sludge management, and we have started the process of understanding that how sludge is generated, what are the different steps, what are the characteristics and how much amount of sludge is produced in each of the production stages. So, there are different wastewater treatment methods, and each treatment method has different amount of sludge which is produced. Now, this sludge which is produced also has different characteristics in terms of how much is the dry solid content and how much is the water content, and depending upon other characteristics also, whether the digestion has happened during the treatment process itself or not, the characteristics will be different. So, we have to use sludge digestion or not, that will depend whether the sludge digestion initially happened during the treatment itself or not, and finally, we have to dewater the sludge. So, there are different strategies for dewatering that we will be studying further on. So, we will be continuing with respect to discussion on the sludge management in next few lectures also. So, thank you very much for today.